solid, liquid and gas.
I'm Megan, this is Elizabeth, and this is our report on states of matter.
There are 5 known states of matter, and there may or may not be more that we have not yet discovered. We have plasma, Bose-Einstein condensates, and as we have already seen, solids, liquids and gases.
We are just going to focus on the last 3 because they're the only ones you need for GCSEs, and the best way to explain states of matter is with these. That's right, Maltesers.
Here is a solid. As you can see, the solid maintains its shape even if you put it in a container. Now let's imagine each of these Maltesers is an atom of metal, and all we have here is a piece of pure metal.
All atoms and molecules vibrate if there is heat energy. So, if we have a substance that is above 0 degrees Kelvin, we have heat energy, and the more energy there is, the more atoms will vibrate. Solids can absorb a lot of energy. The solids might expand, and eventually, if there is enough energy, the bonds between the atoms will break and the atoms will become free-flowing. The solid will have become a liquid.
And here is our liquid. The first thing you notice is the fluid nature of the atoms because the bonds are so weak. You will also notice that the liquid will change shape to fit its container. The more heat energy is applied, the weaker the bonds will become, and the liquid will become more fluid.
We can see this in nature. Very hot lava will flow quickly from volcanoes. As the lava cools, it becomes less fluid until it cools down into a solid. When waterfalls freeze over and become solid ice, they will gradually absorb heat energy in the spring, and the ice will return to its liquid state, water.
But the story isn't over yet. What happens when you apply so much heat energy that the bonds between the atoms are completely broken and the atoms become completely unattached and free-moving? You have turned your liquid into a gas.
That's right. There is now so much heat energy that we have randomly moving, completely disconnected gas atoms. Gases will expand to fill the space that they occupy. Given the opportunity, a gas will fill any volume. We are now going to do a practical demonstration. Let's head to the kitchen.
Earlier today we were making fridge cake and flapjacks. In other words, we were using our understanding of kinetic theory to make snacks for school. Here is a block of solid chocolate. The molecules in this bar are vibrating, but as there is insufficient heat energy, the bonds are intact. The chocolate has not melted. Time to apply some heat. This is a bowl placed over a pan of boiling water. It's not bake-off, so I won't go into an explanation of the cooking procedure, but it's done to avoid burning the chocolate. Heat is applied and the bonds are vibrating more and more, and eventually we have liquid chocolate. But what about chocolate gas, you ask? Well, this isn't Willy Wonka, so we're not going to ask you to smell the film, but take it from us. There is a lovely aroma of chocolate. Some of the molecules absorbed enough heat to become gaseous. By breathing in, I can capture those molecules in my nose and smell the chocolate. Let's look at what these processes are called. When a solid turns into a liquid, it is called melting. When a liquid converts into a gas, it's called boiling. It is possible for a solid to be converted immediately into a gas. This is called sublimation. We can now look at these changes in reverse. Let's start with a gas. Steam is a good example of a gas. Obviously, we're starting the procedure with a lot of energy. As soon as the steam comes into contact with something cooler, it could be air or another solid or liquid, energy will start to be transferred away. The gas will cool and become a liquid. Here you can see some droplets of liquid water. This is condensation. If the water droplets continue to lose energy, the water molecules will vibrate less and less until they form ice. This, as we know, is freezing. It is possible for a gas to transform directly into a solid. This is also called condensation. At Science Rocks, we're always looking for innovative ways to help ideas and facts stick. So now that you've seen this film, buy a box of Maltesers and have a go at explaining the difference between states of matter. Science has never been any more fun. That's right. Eating chocolate can help you learn about chemistry. In the rest of the films in our series, we will look at diffusion and some special laws that apply to gases. This is Science Rocks.